So in today's video, we'll be editing a VRM model in Unity. We'll be downloading a model from VroidHub, editing it in Unity, and exporting it back to VroidHub. Now in this video, we'll discuss everything that's possible to do in Unity in regards to VRM1 format. And if you're interested in learning about VRM0 model, you can click on this video. Now, in order to edit Unity, we will need to download Unity. So the easiest way to do this is to download Unity Hub. Unity Hub is a standalone application that will allow us to install all sorts of versions of Unity. So we'll download Unity Hub and install it. Once it's done, you will need to register, make an account, do the setup. Once installed, you can run it. So once we downloaded and installed Unity Hub, we'll need to install the Unity version itself. So in here, you'll need to register and you'll need to make an account, and then you go into installs. And then once you go into installs, you go into install editor, and here you will need to select a version of Unity. Now, the one that I'll be installing is Unity 2022.3.6 F1. So it might be available for you here in the official releases. If it's not, you can go into archive and then download archive. Depending on when you watch it, it might be out of support. So we go in 2022 and then we find 0.3.6 F1. Now it's not here. We can see that the latest one was a 0.59. So it should be somewhere over here. Now I already have it installed and it's here. So now that we have Unity Hub open, we will need to start a new Unity project. So we'll go into projects and we will create a new project. In here, we specify the editor version and we want to use 2022.3.6 F1. We click to use the 3D built-in render pipeline and we will name our project. We will name this one VRM1 models. And then we click create project. And then we simply wait for it to load. And now that we have loaded into our Unity project, it's a very good idea to run it once to make sure it works properly. So we'll click the play button and we can see that we have some errors and we cannot play. If we check the console output, we will see an issue with some packages. This is an error that sometimes happens upon first startup, so the easiest solution to try is to simply close out the window, go back into Unity Hub and simply launch the project again. And now when we hit the play button, you see that the project loads and we don't get an error anymore. We set up our Unity correctly. Now when you start your Unity project for the first time, your scene will not look like this. This is just how I have it set up. In order to work with Unity, we will need the following windows. The first is the hierarchy window, second is the project window, and third is the inspector window, and then we will also need a scene window and a game window. If you don't have any of these windows, you can click these three buttons here. You can click add tab, and then you can add any tab that you want. And when you have this tab added, you can move it around, you can drop it and drag it, you can resize it or scale it, and if you don't want it, you can also press the X button to close it out. Now let's go through some basic navigation. So in the scene menu, make sure you have the scene menu selected, and in here you can zoom in and out scroll wheel. You can move around your viewport using right mouse click. You can select objects with the left click, either by selecting them in the scene menu or selecting them in the hierarchy. Then you can zoom in on an object by pressing the F key on your keyboard. Here you have buttons which allow you to move objects around the scene. I recommend always having this button selected, and this button allows you to move the object around in all directions. As you can see here, we're moving the sun around. Now we have Unity set up, but what we don't have is support for VRM models. To do that, we will need a package called UniVRM. UniVRM is downloadable from GitHub. And to download it, we will go into the Releases tab. We will download version 1.28.3 because it is the newest one. And in here, you will see that UniVRM supports 2022.3. And this is why we downloaded this specific version of Unity. So now we will download the VRM1 package by clicking the download button over here. And as you can see, we have it downloaded here. Now it's important to download this one because VRM0 works in a different way. And also you need to make sure that you do not have both of these packages loaded. So once we download the package, we simply click on it to open it, and it will open itself in Unity. And in here, as you can see, these are all the new files that will be added. You'll just click import. And once the file loads, we will see this Unity editor settings validator window. It says that the recommended color space is linear and we're using gamma, so we will agree with the changes and it will change our color space. And now it says thank you, and we're all set. Now that we have added VRM1 support, we can double check that it's working properly by seeing that we have these two new folders, and as well we also have these two buttons. When we hover over them, we can see that we have menus, and we know that we have added VRM1 support properly. Now what we will need is we will need a VRM model. Here is a model that I found on VroidHub. If we scroll down, we can download this model and we can work on it. So in order to work on this model and keep things organized, we will make a new folder and we will name it something like butterfly model. We press enter to enter it. In this empty folder, we will simply drag in our VRM file. And in here, we will also create a new scene, and we will name it butterfly model, so as to keep things organized. We will also open it by pressing enter, and we can save the sample scene, sure. And now we are in the butterfly model scene. Now, when it comes to editing models in Unity, VRM is backwards compatible with VRM0 models, or to be more precise, if we click on this model, we will notice that it was a VRM0 model, and we have a button here which says that this model was migrated from VRM0. So in this Unity project, we can work with both VRM1 models and VRM0 models. The only thing is that when we export the model, it will always be in VRM1 format. So we will drag this model into the hierarchy here. We will press the F key on our keyboard in order to focus on. In order to work on the model, we will need to extract some data from the model. So to do that, we will click on the model here. We will go into the materials section and we will click extract materials and textures. Then we will go to the VRM tab and we will click extract meta and expressions. Once that's done, we will click somewhere in the scene and it will say that the settings were unapplied. So we will click save to apply the settings, or you can also click this apply button over here. And now we will notice that we have these three folders, and these three folders will contain all the data for our model. When we were working with VRM0 models, this data was automatically extracted for us. When we are working with VRM1 models, we will need to extract this data manually. In here, we also have the clear extraction button. You will never want to click this button because it will just undo your progress. Now that we have extracted everything from the model, we can start working on the model. When it comes to editing the model, the main thing you most of the time wanna work on is materials, so that's exactly where we'll start. If we open this folder, we will see all the materials that the model uses. Materials control how the model looks like. So let's begin with probably the most frequent change, the hair. I want this hair to be changed, and we'll go through all the settings and I will explain what each setting does. The first option that we have here is called edit mode, and here we can select between basic and advanced. In general, I recommend keeping it on advanced, and and then we can go through the rest of the options. Now, next is rendering, and the first option is alpha mode. Now, in VRM0, this was called rendering type. And here we can see that we have our familiar options: opaque, cutout, or transparent. If we select either one of these, we will notice a new menu appear, either transparent with zeroite or cutoff value. We will return to this alpha mode later. Next is double side. In VRM0, this is called cull mode, and here we have the option between on and off. The difference here is that, for example, let's look at these wings. From one side they are visible, whereas from the other side they are invisible. If we check the wings material, in here we can see double-sided. And if we turn that on, we will notice that the wings are now visible from both sides. In VRM0 format, you had the option of culling multiple sides, that is the front, the back, or both sides. In this case, we have the option of double-sided. And in general, I recommend keeping a double-sided on for all materials except for body and face. Now let's return to our hair material. Next, we will have a render queue offset. And as far as I can tell, this doesn't seem to do anything. You can enter any value, but it will not matter. In the future, this will likely be used to assign which materials have priority. Currently, any value set will be defaulted back to 0, so that means that all materials load at the same time at the same priority. Next, you have light. And here you have lit color and shade color. As you can see here, we have a texture assigned both to the lit color and the shade color. This basically describes how the model is colored. And next to that, we also have an actual color that we can select. So in this particular case, I want the hair to be white. And in our case, the texture is already white. So all we need to do is simply select the lighting color to be more white. And when it comes to shade color, I recommend setting it slightly darker than the lit color. Next up, we have a normal map. And what normal maps do is they add detail to the model. For example, if we select this normal map, we will notice added detail on the hair. Normal maps are a cost-effective way to add detail to models. And here we can also select the normal map intensity. So for example, we could use something like 5, or we could use something like 50, or we could use something like 0.1, where it's barely be visible. Now, I personally don't want to have a normal map, so I'm just gonna unassign it, and we'll move to the next variable. The next variable is called shading tuning. This variable basically allows you to change the shading type in realistic and tune. If, for example, we select it below, the shading and the hair will appear more realistic-like, and if we set it to the maximum, we will notice the sort of cel-shaded look. This basically describes the transition between the lit color and the shade color. And in general, the default value is. Next up, we have the shading shift. And what shading shift does is it basically describes where the border between the highlights and the lowlights are. This property is also present in VRM0 models. If, for example, we increase the shading to tune and then we change the shading shift, you will notice the area where the highlights are shrink or increase. In general, the default value is fine. Also, when changing these parameters, you will notice this error message. You can ignore it, it does not matter. And in general, the default value is perfectly acceptable. Next, we have a parameter known as additive shading shift. What this additive shading shift does is basically you can assign a texture to it, and then this texture gets overlaid on top of this texture, on top of the shade color. And here, with this parameter, you can specify the intensity. What we could do, for example, is overlay this texture over this texture with the intensity of 10. And as you can see, we will notice some variation. Now let's use a proper mask instead. So we will lock this material so it doesn't go away. And over here I have a mask that's designed for the hair model. If I apply to additive shading shift, you will notice the areas where there are white, they will receive the lit color, whereas the areas that are black, they will receive the shade color. And here we can fine-tune the intensity. For example, we could select 0.5. This texture will be applied only at half strength, or we could select at 5, but after 1, it doesn't, it still increases a bit, but it doesn't do a lot. And in general, what I recommend is you don't adjust the additive shading shift, but rather you overlay this map on top of this map yourself. That way you both save on resources and you also save on model space. If we were to unassign this and apply this texture to the shade color, you will notice undesired results. But that doesn't mean that we can't combine this with this in an image editing software of our choice. For the purposes of this video, I will not use a shading map because I don't want to. This parameter was also present in VRM0 format, but it was called Lit and Shade Mixing Multiplier. Next is Global Illumination Equalization. And what this does is it basically defines how reactive the material is to global illumination. Now in VRM0, you had global illumination intensity. Here you have equalization, which is the opposite value, the reverse. In general, keeping the default value is fine. If you decrease it, then global illumination will affect the model a lot more. So just keep the default value and don't worry about it. Next we have the emission map, and here you can assign the emission color, for example blue. And here you can also assign an emission map. So we will use this image as our emission mask, and we will assign the emission color to yellow. As you can see, certain parts of the model become yellow. Now the intensity is not that high because the base color is very saturated, so we'll reduce the base color a bit. And here you can see that the emission intensity increases. We will keep something like that. Next up we have rim lighting, and rim lighting is divided into two parameters, that is rim lighting and parametric rim. In VRM0 formats, we only had one parameter that was referred to as rim. In here we have two parameters. So let's first look at the parametric rim. So here we can assign a color. Now I want the rim color to be yellowish. Something like, it's a bit too intense. It's not quite as yellowy as I'd like. Something along the lines of this. Next we have Fresnel power as well as lift. This basically defines the minimum and the maximum power of rim lighting. As you can see, if we increase this is basically like the minimum, and this is kind of like the maximum. So we'll adjust it slightly. We'll increase lift a bit, something like this. Yes, I prefer something like this. Now back to here. Here you can also select the mask, and we'll select the same mask, and when we select the mask, only the parts of the model that have the white part selected will contain rim light. So I want to invert this mask, and the way I'll do this is, first I will open this up in the Windows. First I will open this file in Windows Explorer, and here I will edit this image in my image editing software of choice. Now we have this inverted mask, and I will save it. Here, emission mask inverted. And in here, I will apply this mask to the rim light. And it's perhaps difficult to tell, but if we remove it, you will notice that the entire model receives rim lighting, whereas if we assign this mask, only the selected areas will receive rim lighting, and the intensity of the rim lighting will also increase based on the color of the area. We also have lighting mix, which basically defines how the rim lighting is interacting with the lighting in the scene, in this case the sun. And it's a little bit easier to see without the mask, so here we can see that the change is quite minimal. But if I change the color of the sun to be somewhat blue, for example, you will notice when I change the lighting mix, the rim color reacts more or less with global lighting. This is something that you can figure out on your own, and generally keeping the value as 0 or as 1 is perfectly acceptable. Next is the Matcap property, and Matcap files look like these. Matcap files allow you to apply a pre-rendered texture to a 3D model, which can simulate lighting and material properties. For example, here we can select this. You can use any texture as a Matcap, and as you can see, when we look at the hair, the material stays, giving us a sort of holographic effect. Here I applied this Matcap onto a dress, and it's a little bit easier to see. This parameter is very useful for applying properties such as glass, or metal, or rubber. Then after that we have a property called outline, and it's just what it seems. It gives the model an outline, and here you can adjust the outline width. For example, if you apply this mask, you will notice only that the bits where the white is at will receive an outline. In this case, it does not look particularly good, but with fine-tune adjustments, perhaps you could make something work. Though in general, I highly doubt that you will ever use a mask for an outline. In general, I recommend using world coordinates just because they are always fixed, but sometimes you can use screen coordinates as well. The difference is if we use screen coordinates, you can see when we look close up at the model, the outline width is this, but if we zoom out, the outline width remains the same relative to the screen, but relative to the model, it grows quite large. This is why I always recommend using world coordinates, because they will always appear the same no matter what angle or what distance you look at. Next up, here we also have the outline color, and it's as simple as it sounds. It defines the color of the outline. Here you have outline lighting mix, and just the same as with rim lighting mix, it describes how the outline reacts to ambient light, in this case the sun. So if we change the sun back to blue, for example, or pink, purple, you will notice with lightning mix the outline remains the same color, whereas if we increase it, the outline will change to be in accordance with the sun color. And as we can see here, not quite fully, but mostly. And in particular, we're not gonna be using an outline because we will want to have toggles for materials, and the outline gets in the way of that. Next up, we have the UV animation. Here we have three parameters: translate X, Y, and rotation. In PRM0 format, this parameter was called scroll X per second. So here we can adjust it, and we will see that the texture is scrolling slightly. But in order to preview this properly, we will need to enter play mode. So we will do just that. If we go back into scene, we will notice that the material is scrolling. And to be more precise, It's this texture scrolling in the positive X direction. So in this case, it's scrolling to the right, which on the model appears to the left. And this value basically says if it's 1, that means that the entire length of the texture will scroll 1 time every second. Y direction is exactly the same thing. Since it's scrolling in the positive Y direction, it appears to be moving down on the model. And the rotation value is exactly as it sounds. It describes the rotation speed of the texture. Now, one difference here is that in VRM0, you had a selection between rounds, degrees, or radians. Here, you do not have this selection. By default, the value is set to rounds, which means if it's set at 1, then that means that this image will turn around once every second, probably. So now we will exit play mode, even though we can still edit materials in play mode. One additional thing to note here is that in VRM0 format, we had the option of tiling a texture or offsetting a texture. In VRM1 format, we do not have this option anymore. It is no longer supported. This is something to note. And the next menu we have is called debug, and this is automatically generated for you. You do not need to pay attention to this menu. Now here, while working on the model, I still see the hair is slightly darker than I want to, especially looking at the highlights. So what I'll do is I will adjust this main image to be slightly brighter. And we can find this image if we go back to a folder, we will see it in here, in the textures that we have extracted before. So here I have increased the brightness of the texture, and then I will save. And I'll go back into Unity and slightly adjust the shading. Alright, something like this is what I prefer a bit more. And you can mess around to set up a model the way that you want. If we also pay attention more to the texture, we could also paint something on here, and if we were to save it, we will notice it appearing on the model as well. This is one way to add detail to models and textures by simply painting the texture itself. Now I will revert this change, and we can proceed with the next step. So now I'm looking at the model. And one thing I'm not very fond of is this crown. I wish to remove this crown from the model. Now, there are two ways to do this. One way is to change the material, whereas the other way is to remove the geometry. So we'll try the first method, which is to remove the material. So we can find the material that the crown is using by clicking on the crown itself. And here we can see that the crown is using a material called gold. Now what we can do is we can change the alpha mode to cutout, and we can increase the cutoff value to maximum. And what we see is that not only the crown disappears, but the necklace also disappears. And the necklace disappearing is not a property that I want. So we can undo the changes, and we can undo the cutoff value. And if we click on the necklace, we will notice that it is also using the same material called gold. So if we want to preserve this and remove the crown, we will need to duplicate our material. So we will go into the material section, we will find the material called gold, and we will hit Ctrl D to duplicate it. And here we can find the necklace again, and in the material section, we can apply the new gold that we just made. Now when it comes to the old gold, we will increase the alpha cutoff value to make it disappear. And as you can see, the crown disappeared, whereas the necklace still remains. Now, one thing is that we've made this new material which did not exist in the model before, and as such, it is not included in the model's metadata. Now, unlike with VRM0, we cannot add this material to the model's metadata. Unfortunately, the only way to do this is to export the model, which we will have to do. But let's look at our gold material first. We've made it invisible by increasing the cutoff value. The problem is that this parameter is not respected in all applications. It is respected within Unity, but other applications may not respect it. So another way to make this material invincible is to simply remove all the data and select all alpha values as 0. So here we will remove the materials, and here we will select the color as black, and we will change the alpha value to 0. We will also do the same for the shade color. We will also remove emission maps, rim lighting maps, matcaps. We will change all colors to 0. And now in all applications that support the cutout feature, our crown will appear as black. Now we've made this new gold material and it's looking rather red. I am not a fan of that and I want it to look yellowish or gold-like. So I will change these parameters to see if I can make it look a bit more like gold. Now in order to give this amulet a gold look, I will use a Matcap that represents gold, particularly this. Yeah, something like that, I believe is fine. So now that we've made this new material, in order to apply it to the model, we will need to export the model itself. So we do that by selecting the model and by clicking the VRM1 and export VRM1. In here we can adjust a lot of properties of the model, but we're gonna come back to this later, so we're just gonna hit export. We will navigate into our butterfly model and we will create a new folder called new butterfly. And in here we will save our new model. We hit save and it exports. And it will re-import the model as well. So here we made the new butterfly folder, and in here we have the new model, and we can see that the model has our new necklace and our new hair that we just made. So in this folder we will once again extract all the materials, and we will also go to the VRM tab and extract meta and expressions. And then when we click off, we will be prompted with a save, and we will do exactly that. Now, one thing about VRM1 compared to VRM0 is that when it comes to the inspector window, VRM1 is slightly less capable at handling windows. Sometimes there will be some weird stuff where materials might not load, where things might not be displayed properly, so just a fair warning. Now that we have this new model, what we're gonna do is we're gonna delete the old model by pressing on it and hitting delete. Now we can drag this new model into the hierarchy, and we will notice that it has all the things that we set up. So this was the first method to remove a material. Now there is a second method to remove the material, and that is to delete the geometry of the material itself. And we do that by clicking on the geometry in question. As you can see, it highlights yellow. That means the thing that we want to delete is selected, and we simply hit the delete key. Now, as we can see, the geometry has been deleted, but the metadata has not been deleted, and that will cause problems, same as it did with VRM0 models. So in order to do that, we will need to click on the model in the hierarchy, and here where it says the VRM instance, we will select the UI VRM instance, and in here we will go to the VRM file. And when we double click on the VRM file, we can also navigate it by going into the VRM assets, and here is the VRM file. Here we will select the GUI of first person. And in here, we will notice the property of renderers. And in this property, we will need to select the property of headring and delete it. That was what our crown was called. If you have the property here, but you do not have the property here, that will cause problems, because this will be looking for the property that no longer exists. And unfortunately, we cannot update this list dynamically. This list is only updated upon importing the model. This is slightly different from your M0. So this is exactly why we had to update this model by exporting it and re-importing it back, because our new assigned material was not present in the model's metadata. And this is the way you delete a mesh from a model if you have your own defined geometry. Now, the problem arises that sometimes you may not have a defined geometry. In other words, you do not have a thing that you can click on and that will highlight itself yellow. In that case, you will need to change the material. So hence why you have two different methods. Now, when we go into the material and go to edit, for example, a texture, we'll notice that we have duplicates of everything. And that's because we made a new model and we extracted all the assets again. So one thing we can do is we can go back a few folders and we can delete all of these files because these are no longer necessary. Hit the delete key and we delete them. Now, whenever you delete something, it gets deleted into Windows recycle bin. So make sure to delete files from there as well. Otherwise, it might take up a lot of space. Now that I'm here, I also want to make a few adjustments to the model. So here I will want to have the wings white with yellow highlights as well. Here we will go back to the materials and we'll go back to the wing material and we will lock it. I believe I will have to change the Matcap. So let's find this Matcap. Let's open it up in our image editing application of choice and I'm gonna slightly edit it. Alright, and here I've edited this Matcap, so let's save it as new. And let's assign it to the Matcap. You can see that it's probably a bit too extreme, but if I no, that doesn't quite work. I believe I will need to edit the wing texture itself. So let's do that. Alright, well, it took quite a bit of fiddling around before I managed to get what I wanted, but this is something closer to what I wanted to get. I did make the texture fairly white. I assigned an emission map, and the Matcap I did mostly black with just some highlights for the light reflection. And I also added some rim light. Now that I've changed the wings, the other thing that I want to change is the clothes as well. I wanna make them white. So next we'll get the dress material and I'll lock it, and I'll once again go through each step, changing the textures and changing everything else. Well, this was a lot more tedious than I thought it'd be. And I should maybe change the hair. Let's look at the hair again. Slightly too dark. Alright, let me change the hair real quick. Alright, this should about do. Yeah, that's a lot better. That's a lot better. We are keeping similar colors across the board. Now I also need to change boot color. So let's select the boots. Emission map, we'll change it to yellow. Alright, not quite right. Okay, need to adjust the color slightly. Okay, maybe that's a bit too intense. Okay, we'll reduce the Matcap slider. Green. I don't want green. We add some white emission perhaps? Yeah, I kinda like the way that looks actually. Just a little bit. Yeah. Yeah, I think I prefer that maybe. What would this material look like on the amulet, I wonder? Ooh. Okay, I'll assign this material to the amulet as well. Nah, I think this one's probably better. Maybe I could add some highlights to the amulet material though. If we add the same emission mask, what would that look like? Oh, that doesn't look that bad. I think I might keep that actually. Alright, now looking at the model, I still should probably change the tail and underwear. So let's speedrun this. Alright. Alright, I think that's fine. I think that'll do. So now that we have set up the materials, I want to do something else. I want this dress to be slightly see-through. So the way we'll achieve this is by going into the dress material and then selecting the alpha mode. Now in this case we will need to use an alpha mode, either cutout or transparent. Now the difference between the two is in the way the transparency works. In cutout mode, alpha will be either 1 or 0, and when it comes to transparent mode, there will be transparency visible. So we will select transparency and we will enable Z-Write mode. Now what Z-Write mode does is it adds a Z buffer. So for example here we can see that this dress does not have any transparency at all. But if we were to disable Z-Write mode, you will see that transparency does not work correctly. So hence why we need Z-Write mode on. Now the only real situation where you want to have this disabled is when you have transparency on top of transparency, because that is the area where you mainly get issues. Now that we've done this, we also want the dress to be slightly transparent. So I will take the material that was used for the dress and I will slightly increase the transparency. We'll save it. We'll go back. And now we can see that the dress is slightly see-through. It's a little bit too much. Let me decrease the opacity slightly. Yeah, that's fine. Alright. And that's how we make clothing see-through. Now we have our model mainly set up. We can hit play and examine the model. If we go back into the scene, we notice when we move around the model, the hair moves, but nothing else does. For one thing, we need to make the wings dynamic and also we need to make the tail dynamic as well. So that's exactly what we'll do next. Now dynamics in VRM1 work differently than they did in VRM0. So what we could do is we could analyze the dynamics already present at the model by looking at the hair. And to do that, we will go into the model in the hierarchy. We will see this VRM instance. And in here we have the option of select UI. In here we have the option of 3 different UIs. So VRM instance, as you can see, it just assigns the VRM1 file, which we already extracted before. Then we have the look at UI, and You can ignore this, this UI isn't very useful. And then we have the Springbone UI. And in here we have collider groups, and we also have springs. As you can see, these are springs that are assigned to the hair, and these are colliders that are assigned to the model. So in order to add new springs, and that being wings, we will need to add a new spring. So we will click the plus button here, and the plus button will duplicate the previous existing spring, and we actually wanna modify it a bit. So what we'll need to do now is to select the first bone element that we wanna give dynamics to. In this case, we will go to the wings. As you can see, we have a wing base here, and if I move it around, you can see that the wings move. So that's how we know where the bone for the wings is. And if we go, for example, here, we see we have a separation for left and right wing. If we go a bit further down, we will see here we have the top wing, and here we have the bottom wing. And that's about it. Now, there is a difference in how spring bones are handled. In VRM0 format, assigning one wing would assign all the children of the wings as well. In VRM1, that is not the case. For example, let's go back into the new spring that we just added. Now in here, we will try to assign wing base as element 0. And you can see that it doesn't let us. Why doesn't it let us do this? Well, that's because we do not have a parameter assigned in the bone itself. So we need to click on the bone that we wanna edit. We will click add component, and we will add a spring bone joint. If we expand the spring bone joint, you will see all the parameters that the bone will have. These are the parameters that were defined in the VRM0 format when it came to spring bones, but in here we have these per bone. So this is the main difference between VRM0 and VRM1 spring bone dynamics. VRM1 spring bones allow you to edit these parameters per every single bone, per each bone. Whereas when it came to VRM0, the spring bones were edited for the entire hierarchy, not just one single bone. So here, now that we added the spring bone joint, we will go back into the springs in our window over here, and we will assign it to as element 0. Now, if we hit play, and we go back into scene and we move the model around, you will see that nothing happens. And why is that? Well, unlike with VRM0, VRM1 requires a connection between the parent bone and the children bone in order to make one dynamic bone. So in this case, we would also need to assign a joint to the children as well. So in this case, for example, we will assign a joint to wing L, and we will assign a joint to wing right. Now, when we hit play and we try to move the model around, you will notice that still nothing's happening. And why is that? Well, because we forgot to assign bones to the spring group. And we do that by going in here. You can also rename this to something like wings. And in here, we will assign both the left and the right bone. And these two elements, we can delete these two elements. We'll just set free. Now, when we hit play, and we go back into scene, you will notice that only one of the wings is flapping around. Now, why is that? Well, this is because there are some more nuances to these spring bones in VRM1 compared to VRM0. If we go back to the spring bones, only the first child of the joint is able to have spring bone dynamics. If we want to have multiple spring groups, we will need to have multiple springs. So, to explain this a bit simpler, here we have the original, the parent, and here we have the first child, meaning that only this bone will have spring bone dynamics. Then if we expand it, we have the first child again, meaning this child will have spring bone dynamics. Then after that, as you can see, this bone has 2 children, but only the first child will once again have the spring bone dynamics. And if we expand it, we continue, we can see we end up with a path until eventually we end the spring over here. And that means all of these parameters are one spring. And this will have to be a different spring, and this will also have to be a different spring, and so on and so forth. So what we can do is we can automate the process of assigning bones to these springs. So here, we will go back to wing base, we will open up wings, and we will assign it once again, though we already had it assigned. And here we can press this button, create joins to children. And what this will do is this will give us a message. This basically says that some settings will be overwritten. We press OK, and as you can see, it made a path for us. And here in red, we can already see the path where it's going. Now, what it did is it took the settings of the first parent, and it used these settings to apply them to all the children in the hierarchy. And if we hit play, and we try to move the model around, we will notice that the wing starts moving. But we wanna adjust some settings a bit. So what we can do, actually we can adjust this in play mode. We can move the wings about, and I wanna adjust the settings slightly, so maybe let's reduce the stiffness, let's reduce maybe let's increase the drag force. Something along those lines. And only the first bone in the sequence was updated. And here, we can see that the yellow one is being updated. I believe you can change color. Alright, so we'll do something like this. We'll unhit play. We'll go back into spring bones. We'll go back into wings. And we'll press the create joins to children button again. Oh, I forgot to. First, we'll paste the values that we just set. And we'll press this button again. And now, as you can see, all the settings were applied to this path, which were the first children of this bone, till the very end. And now, if we try to do this again, yeah, that's something a little bit better. I quite like how that looks. Alright. But now, I don't want to begin at wing base, I wanna begin a bit later, because when we move the first bone, you can see that all the other bones move as well. So we'll delete this. We'll go this is the first one, maybe? No, we should go a bit later, so possibly this, maybe this. Yeah, let's use this one. Okay. So once again, we'll go spring bones. It's very annoying that these menus don't stay open. And here we'll drag the first element as L001. We'll press create joins to children. We'll make everything back in the end, and it will fix our problems. And here, let's move the actual model around. And maybe that's too much. Oh, maybe not. I kinda like how it flaps around. Alright, let's try to apply this for all bones then. So the way we do this is we'll need to collapse this. And we can see the next child is this, which is the bottom wing. So we'll take one of these settings of one of these bones, because I wanna have the same settings. We'll click copy component, we'll go into this bone, we'll click paste component as new. As you can see, it's red because it's not assigned anywhere. So then we'll go into spring bones, wings. We'll rename this wings left top, and then we'll click the plus button again, and this will be wings left bottom. Span joints, colliders, and here we'll assign this bone, and then create joints to children. And as you can see, it made a path of bone for us here. If we hit play and move the model around, the entirety of the model, you can see it moves around. There's a few red bones here, and red bones means that they were on a side, and it was these ones. As you can see, there's even a message here: this joint does not belong to any spring. So we'll remove this, and we'll remove these, because I'm not gonna be animating them, I'm not gonna be giving them dynamics. And yes, it was this left 1 and left 4. So on the right side we can do the same exact thing. So we'll take this, we'll press copy component, we'll add component as new here, and we'll also paste component as new here. Then we'll go back into spring bones. Here, this will be wings right top. You don't need to rename this, the name is not important, it's just so you could keep track of the elements yourself. And we'll assign this here, we'll click OK. As you can see, it made a path for us. Something's unassigned. And then we'll click on the plus button again. Wings right bottom. Bottom. Joints, collider groups. Assign this here. Create joints to children. Yep. Oh, okay. I don't know what that red was about. It's no longer there. And now if we hit play, we will notice that we have dynamics for wings. We move the model about, you'll notice that the wings flap around. Now, the better way to test this is to actually assign an animation to the model. To do that, we will need an animation file. Now, animation files look like these. They have an extension .anim, and we can play them in Unity. All VRM avatars are humanoids, so all of them support humanoid animations. And in order to assign this animation to the model, what we will do is we will right-click, create new animation controller. We'll name it animation. We'll double-click to open it. You'll double-click on this and you will go to the animator window. If you don't have it, you can go into Window Animation Animator. Then you'll open this window, and then here you'll just drag in the animation, and then you will assign this animation to the model. You will press on the model, you will go to animator in the model, and you will drag it into the controller. And now when we hit play, we will notice that the model is dancing. Back into scene. And this is another way of how we can adjust the dynamic bones. Now, once again, with VRM1 standard, you can adjust each individual bone. So we could, for example, go here into bone 9, and we could adjust the settings, for example, increase the drag force. And now this particular bone is a lot stiffer. Perhaps it's difficult to see. Let's actually not drag force, we should increase the stiffness. Yes, we want to make it stiffer, increases the stiffness. And as you can see, that bone made this part of the model a lot stiffer, but the other ones are still flexible because those are the settings that it has assigned. It might be a little bit easier to see if we, for example, adjust one of the bottom ones. So we adjust here, you will notice that the properties change. And there's a lot more fine-tuning that you can do here compared to VRM0, but it's a lot more annoying as well, because you need to work with the mindset that you have individual bones and not an entire tree that you can work on. Now, in this particular case, we already have some colliders set up, and these were colliders that were set up because we copied settings from the hair. The hair already had these set up. So what you can do is we can also examine these colliders. So I'll pause the animation for a second here by removing the controller, and we'll take one of the hands. For example, the right hand. You'll notice that the hands interact with the wings, and that's because we already had some collision set up for us. Now, in play mode, all changes related to spring bones will not be saved, except the edits that you make in VRM instance. I'm pretty sure it will be saved. Actually, let's double test that. I assigned something like this here. Let's see if it saves. No, it doesn't save. Okay, so all edits, all dynamic edits will not be saved when you are in play mode, including these. So you can experiment in play mode with as many settings as you want. But just keep in mind that they won't be saved in play mode. Now that we made the wings dynamic, we also need to make the tail dynamic. And we will do this in a very similar way. We will simply go to tail, which is, I believe, hips 1. And we'll select, I believe, element hips 4 for our dynamics. So, in order to do that, we will click the plus button to add a new element. It will copy the properties of the last used element, so we'll just name it tail. And we will assign this bone. Oh, that's right, we need to assign a spring bone joint to the component itself. Then we'll drag it into here, and we'll click the button create joints to children, and then it will select all the children of the tail. And here we can adjust some of the parameters. Size is fine, perhaps I'll make it a tad bit smaller. What about the properties itself? Let's see how it flaps around and moves around. Well, I don't mind the way that it flaps around actually, but it is clipping quite a bit. Though I think I will slightly increase the stiffness so it just doesn't move just that much. For example, maybe let's keep the value here, and we'll go back to the tail. We'll click this button again to apply these settings to all the bones, and now we'll try this again. Go back into scene. No, I believe that's too much stiffness, not enough tractors. Alright, you're learning. So let's try this. Go back in here, create joints to children, press play. Yeah, I kinda like how that looks. Alright, we'll keep those settings. But now I noticed another issue, is that the tail really likes to clip through the skirt. So how do we fix this? The technique is actually different from how we fixed the VRM0 model. In VRM0, we went into edit mode by double-clicking the model. We can't do that in VRM1, because if we double-click it, it will try to open the program within Windows. So that's not how we're gonna do. What we're gonna do is actually adjust the position of the bones in here, in the hierarchy. This will be saved upon export. In VRM0, this probably would not have been saved upon export. Maybe in some cases, but maybe not in all cases. But in here, we can actually adjust these. And we can adjust these slightly. Just their position. Something like that. Can adjust these as well. Maybe this as well. And let's hit play. Let's see how well that works. Yeah, I mean, it's clipping a bit, but that's probably just because this animation is like that. I think I should adjust it even a little bit more. Certainly won't hurt. Yeah, let's do it like that. You straighten out the tail a bit. Yeah, I mean, it's clipping a little bit. What I could do is I could probably set up a collider next to the butt somewhere, and that might prevent the clipping. Well, let's do that. That's another way to solve clipping problems, is using colliders. Now, colliders work kind of similar how they did in VRM0, except they're a bit more complex. So we'll go into hips. And here we will want to have a spring bone collider. So we'll have to adjust normally. So we'll assign the collider over here. So that this way, now this collider will follow the hips. And whenever the tailbones hit this collider bone, it will not go through it. So it will collide with it, and that should prevent some clipping. But when I think about it, I probably need a couple more. So I probably need one here, and I probably need one here as well. So we could add another sphere. But VRM1, another difference is that it supports other kinds of colliders. So here, we don't have to only use spheres. We can select one of these. We can select a capsule, which will add a capsule. As you can see, we can adjust the tail position, we can adjust this position. Now it's easier to illustrate with some examples. So for example, here we have a sphere collider, and this sphere collider, this ball is interacting with the other balls, the ones present in the wing. And here we can change it to a, for example, a capsule, and we can increase its size. And the capsule is exactly how it sounds. It's the shape of the capsule. We can change one part of the capsule, and we can change another part of the capsule. And as you can see, when it interacts with the bones, in this case the capsule interacts with the spheres and the wings, and we have dynamics. Now, what we also have here is we have a plane, and a plane will be infinite. So here you have an image of a rectangle, and as you can see, when it collides, it will collide with all spring bones that are present, and it will collide into the infinity as well. Plane colliders are generally used for adding collisions with the ground, and here we have some parameters here. So we have normal, and what normal does is it basically just defines the direction. As you can see, here we have this purple thing sticking out, and it defines which direction is up. So we could, for example, change it to that direction, change it to that direction. We could change it over there or over there. And we could change up and down and around. And then we have some other types. So sphere inside. What sphere inside will do is it will basically attract the spring bones, and it will try to make them be present inside the sphere. So the balls that were in the wings, they will try to go within the ball itself, or in other words, they will try not to leave. So here we can increase the radius a bit, and you see as we shrink the sphere, the wings also get trapped inside, let's say that. And that's basically what the sphere inside does. I'm not sure where this could be useful, but this could probably be useful somewhere. And then we have also capsule inside, which is the same exact principle, except in this case we have a capsule you can set this position back and forth. And once again, the assigned spring bones will try to remain within the collider, and they are not allowed to leave the collider, so to say. This is could also be used somewhere. And if we hit play, none of these settings will be saved because we added them in play mode. So once again, we'll go back to the hip collider that I wanted to assign. And I think I'll do a capsule collider instead. I think that will be the easiest to understand and the easiest to edit. Alright, if we do something like that, and we assign this collider to the hip, so it will now always be tracked and linked to the hips. So now, what we need to do is we need to assign this collider so that it would interact with the tail. To do that, we will first need to create a collider group. And we can do that by scrolling down. We will notice the secondary component. Because this was a VRM0 model, we still have the secondary component. And in here we have Springbone Collider Group. If we open it up, we will see the colliders that are present. So this group is called the left-hand collider, and it has 3 spheres attached to it. And the same for the other hand. Now, what we could also do is we could do another Springbone Collider Group. And we can name it Hips Tail Collider. And in here, we will click plus to add a new collider. And in this case, we only had the hips. For example, if we were to add hands, you can select which sphere you want. So to select sphere 1, sphere 2, sphere 3. In this case, we only have one capsule attached to the hips, as you can see here. But we'll come back to this a little while later. So now that we made a new Springbone Collider group, we will need to assign this Springbone Collider group to the tail. So to do that, we will click on the model. We will go to Springbones. We'll scroll down. We will go to the tail. And in here we have collider groups. In here, we will need to click the plus button to assign another one. I don't mind if the hands interact here. And we will need to click secondary. But the problem is that we don't really have a choice. As you can see, it duplicated the left hand. So what we'll need to do is hit the plus button here, and we'll need to click the secondary again. And you notice that it assigns the left hand collider here as well. So this is a problem. As you can see here, it was able to assign a different collider, but we cannot adjust this. We only have the choice of this element. This is a bit of weirdness with the VRM1 format. So when it imports a model automatically, it automatically assigns these groups for you, and it automatically knows which collider represents what. But when we do it manually, we do not have this option. So we need to adjust this manually. And the thing is that when it comes to the collider group, the first collider group will be selected. And the thing is that in a lot of applications, this is also the case, that they will only select the first collider group, and they may ignore the second or third collider group, even though it is assigned within the metadata and within the collider groups. I know, it's quite weird. So we need to fix it so that it always remains consistent and it never causes any problems. So to do that, we will click on the model, and we will right click it, and we will select create empty. And here we'll just name it something like right hand collider group. We lock this. We'll go back into secondary, and we will lock this as well. And here we'll press this button, and we'll just do copy component, and we'll also do remove component. And And here we will do paste component as new. And all we did here is just transfer the collider from here to here. And we need to do that for these as well. So for left hand collider and for hips collider. Here we'll do left hand collider group. We'll uncheck this. We'll copy component. We'll paste component as new. And we'll remove component here. And then we'll also do the same thing for the hips tail collider. So we'll right click here, create empty, hips tail collider. You'll click this button, copy component, paste component as new, and we'll remove the component from here. And now the secondary is now empty for us, and we have these 3 groups instead. So now we can assign them properly. If we go back to the model and we go back to Springbone, you will see here we have errors, missing. That's because we deleted them. So we need to reassign them. So this will be hips, this will be left hand, and this will be right hand. The order doesn't really matter. But if we go back into springs and we go to collider groups here, we will also notice that they are missing here. Once again, that's because we unassigned them. Now, strictly speaking, if it was automatically set up for you, you don't necessarily need to make new collider groups. The reason why we did this is because of support in different applications. VRM1 format is still relatively new, and there's still quite a bit of weirdness when it comes to how it's handled within different applications. So in this case, if you do it like this, it will work perfectly fine within all applications. So that's why I'm showing you this method. And what we'll need to do is we will need to fix the colliders for all the Springbone groups that we have. So here we'll need to click the button and we'll need to reassign the right hand and the left hand collider. If we have a missing parameter here and we hit play, you will notice that none of the dynamics work. And that's because we have missing parameters. If we have missing parameters, the dynamics break. So if you made new groups and you notice your dynamics isn't working, that's probably because you have some missing parameters somewhere that you need to take a look at. So here now we have the arduous task of reassigning everything again. And here we are. Now when it comes to the tail, we'll assign all 3 colliders. And now if we hit play, we will notice all the dynamics work properly again. And now if we take a look at the tail, well, we did mostly fix the clipping. I mean, it's still clipping a little bit. If you click on the model, you can see how the tail moves, and it's clipping here on the side where I didn't set up a collider, but as you can see, this collider very successfully prevents the tail from clipping. It's not perfect, but with enough playing around you can get it to be as perfect as you want. For me, I'm happy with this. I'll say that's okay. Now, as you noticed, it is a lot more annoying to set everything up. It's a lot more faffing around. But at the same time, you have a lot more customizability and a lot more features. You can have Springbone settings per bone, and at the same time, you have a lot more robust collider settings. So the way I recommend you set up Springbone dynamics is to make the model within VRM0, assign the bones that you want within the VRM0, and then import it into VRM1. When you do that, all your spring bones, all your collider groups, and all your collider settings will be automatically assigned for you, and they will be automatically done. And it's a lot easier and a lot more convenient than to manually do everything. But we're not done yet, because if I hit play, so the tail isn't clipping through the back of the skirt, but it is clipping through the front, and particularly through the legs. And I wanna fix that. So the way we'll do this is by simply setting up even more colliders. So I want to set up colliders for legs. So I'll find the appropriate leg bones, and I believe in this case it will be the left, yes, it will be the upper leg bones. Okay, so in here I wanna set up more colliders. I will add component, spring bone collider, once again, and in this case we can do a capsule and we can do a sphere. I think that will be fine. We'll adjust the radius a bit. We should, okay, that's maybe, and then I'll adjust the tail position. Yeah, something like that. We will a collider like this, and then I will also add another collider, which will be a sphere, and this one I will add on the knee. 0.5. There we go. There we go. Now I have left upper leg collider. So I'm gonna lock this element, and I'm simply gonna copy these components, and I'm gonna paste them on the right leg as well. Paste component as new, and here copy component, paste component as new. It's a bit off. That's good enough for me. You can adjust it how you want. Now, additionally, what we could also do, the same way we did it in VRM0, we could right click and create empty, and we could just call it left leg collider. And in here we could add collider, bone collider groups, and it would be perfectly fine, perfectly acceptable. In this case, we did it directly on the bone itself. In general, there's no real difference. You can do it however you prefer. But we will also need to make 2 more new collider groups. So we'll go here, we'll do create empty, and we will call this. And here we will add component, we will add spring bone collider group. And in here we had 2 colliders. So we had a capsule and we had a sphere. So in here we will select left upper leg, and we will select left upper leg. But in here we can reselect which object you want. As you can see, now we have both only capsules, only the first one is selected. So here we will reselect the sphere. And now you can see we have both selected, both the capsule and the sphere. And we wanna do this to the right leg as well. So we'll go here, we'll do create empty, and we will do right upper leg collider group. And here we will add another collider group. We'll do, actually you can do just one, and then we'll select the up, and then we just hit the plus button and it just duplicates the last value. And here we will once again reselect it to a sphere. Now that we've done that, we just need to assign these collider groups to the tail. So to do that, we go to model, we go here in the VRM instance, we will go to spring bones, we will go to tail, we will go to collider groups, we will hit plus plus, and we will add them here. Right upper leg collider group, and here is the left upper leg collider group. Now that we've done this, we also need to assign them in collider groups here. If we hit play, you'll notice that it does work. The tail does not clip through the legs, even though we did not assign it in the fallback group, which is weird because that shouldn't be the case, but yet it is. So we'll go back to spring bones and we'll assign it here as well, even though apparently we don't have to, but at the same time it works. And you notice here we don't have the text that says right upper leg, left upper leg. And that's because we forgot to set up the text. And the text box is right here. It says name. So we'll just copy paste this here. And we'll just copy paste this here as well. Now if you go back here, you notice we have text. Okay, now that we have this model, I wanna add a weapon. I think this model could really use a weapon. So I'll drag in a weapon file, and this is a file that I found on the internet. In general, you should use FBX or GLTF format for models, though some other formats work fine as well. And you can see if I drag this sword on the screen, it looks like this. So what we'll do is we'll delete it from here. I'll click on it, I'll go into the materials, and I will extract materials and textures. In this particular case, this file is GLB format, so we see this interface. I'll hit apply. And here, if we open this folder, we have sword textures, and here we have sword material as well. If we click on it, you will notice that it is using the shader standard. Now, standard shaders, I believe, are not supported in VRM, and the ones that are supported are VRM 10 shaders. So that's exactly what we'll do. We'll click on the shader here, we will go VRM 10, and we will select the MTune 10 shader. Now in here, I'm gonna drag the sword into the hierarchy somewhere. We'll just drag it somewhere in here, and you notice the sword, and it doesn't look quite right. So we'll go into the materials, and we need to adjust this material a slight bit. So we'll unlock this material. We will go into advanced edit mode. Just by going into advanced edit mode, you can see a lot more detail because now we have a normal map that has been loaded. So we'll go into textures. We need to assign a shade color. And the thing that we do with the shade color, we just make it slightly darker. We'll keep this tuning. Shading, and in here, I'll probably wanna do gold emission, maybe white emission. No, probably gold, and maybe not as intense, maybe just a little bit. Just slightly, something like that, perhaps. Do I have a Matcap of any kind? What about this Matcap? I have a gold Matcap, would that work? I need to just the intensity a bit. That sort of works. That sort of works. Okay, so now that I have the material set up, I want to apply this to the model. And how do we do that? Well, we can't edit the model. If we double click it, you'll see that it just wants to open in Windows. So that's not how we do it. What we actually do is we simply drag it in the hierarchy here. So here in the left hand, we will drag in the sword in the left hand. And it appears somewhere where it doesn't quite really belong. So we'll resize it a bit. And we'll drag it into the appropriate hand. Now keep in mind, left and right, it is the model's left and right. So if we face the same way that the model is facing, left is over here and right is over here. So now we'll position it properly in the hand. Something like that. Maybe I should make it slightly bigger. Yeah, something like that. Maybe decrease on this scale and increase like that. Yeah. And here, now that we have this model, I'm gonna also rename it to left sword curve. This will be important later, because I will want to have two swords in each hand, and I will want to have toggles for both swords. So to do that, we will duplicate the sword now that we have all the parameters. And we can very simply duplicate it by just clicking it in the hierarchy and pressing Ctrl D. And as you can see, we have duplicated it now. And we can drag it directly into the right arm. And the right arm is here. So you just simply drag it over here. And now that we have here, I will rename this to right sword curve. And if we take the parameters from the left sword, we can copy these parameters, copy component, and we can paste them into the newly made sword. And you'll notice it ends up in the other hand. Now it did just basically just copy the position, so we need to adjust it to fit within the hand as well. But we can do that no problem. And we'll try to make it symmetrical so that it looks nice. Here we have these two swords. And what I'll do is I will go into the texture and I will take this texture gold color sword, this one newly that was made, and I will press Ctrl D on it to duplicate it. And now we can rename this one to right, and we will rename this one to left. So now I can assign this one to the left sword and I can assign this one to the right sword. And that's because when we make toggles, we will make toggles based on the materials that are within the model. That's how we'll use the toggles. So that's why we need two different materials for each sword. Now we did add the sword and we did add these materials, but we did not assign them to the metadata of the model. And that is important because we cannot make toggles if we do not have the materials within the metadata. So how do we assign them? Well, unfortunately, we cannot assign them manually. We will have to do it by exporting the model and re-importing it. To do that, we will go back into the folder and we will make a new folder called new butterfly model. And in this folder, we will export our VRM1 file. So we select the model in the hierarchy, we go into VRM, export VRM1. We'll ignore these settings for now, we'll come back to them later, and we'll hit export. And in here, we'll go into the assets, we will go into the butterfly model, we will go into the new butterfly model, we'll open it up, and we'll hit save to export. Now that we have exported the model, we can delete the previous model that we just worked on. You hit delete. We can delete this from the hierarchy as well because we no longer need it. We just made the same one but new one. And we can drag this into the hierarchy. As you can see, all our settings are saved. And in here, what we'll also need to do is we'll need to click on the model and we will need to extract materials and textures. And then we will go into VRM and we will hit extract meta in expressions. Then when we try to click off, you will notice unsaved changes, we'll hit save. And here we have a new model with everything that we set up. And if you hit play, and we go back into scene, you'll notice that we have all the dynamics and everything's working properly as it should. The only thing is that I forgot to unassign the animation, and as you can see, in VRM1 it was automatically removed. In VRM0 I believe it doesn't get automatically removed, but instead it causes problems, but I'm not certain, maybe it does get automatically removed as well. So now we have the model and now we have the metadata fixed. So what we can do now is we can add some expressions. So to do that, we will need to find a folder that contains the meta files, and in this case it is here, VRM1. If you open it, we will see this information. Here we have the select GUI, we have the meta GUI, and the meta GUI has this. We will edit this in a different way, so for now we ignore it. And then we go into the expression menu, and here we have all these expressions, and we have custom clips over here. So we'll freeze this menu so it doesn't go away. And if we double click it, we can open it up our expressions and we can see what they do. So for example, this is the happy expression, this is the angry, this is the sad, this is the relaxed. And you'll notice that we do not have a surprised expression. And that's because this model was imported from VRM0. And the surprised expression is not a requirement of VRM0. So we will try to set up this expression now. To do that, we have the following settings. So here we have preview weight. This value determines the weight of the animation in the preview. So if we go back to the angry expression, for example, as you can see, if we tweak it, it will become less significant. Now, this slider only works in the preview. So when you export the model, it will be ignored. So you should always leave this slider as 1. In all honesty, I don't even know why you have this slider. I don't know why it's important to know the preview weight, but since it's there, it's there. So we'll go back into our surprised expression, and here we have the first option, which is morph target. This basically lets us select from which mesh we want to adjust the blend shapes. In this case, it's the face, and these are all the blend shapes that we have on the model. So not a lot, but we can still work with these, and we could make some sort of surprised face. For example, something like this. Sometimes setting up the same values within different expressions may cause problem, but sometimes it may not cause problems as well. So let's say I want to create a new expression. So to do that, we will go here into the custom clips and we will hit plus to add a new expression. Now, as you can see, in VRM0, it was automatically populated for us. In VRM1, that does not happen. So we need to create this manually. And to do that, we will go here in our expressions folder, we will right click create, then we go into VRM1 and we go expression. And we will name this one screaming, because this is the expression that I want to have, screaming. So we drag it in here and we double click it. And when we double click it, you see that it opens up here, but we do not get to see our model. And we do not get any of the parameters, and that's because we did not assign a preview prefab. To do that, we will click this button here and we will assign our model. And now we'll make the custom expression. And something like this is fine for me. Now, what blend shapes you have will depend on the model itself and what you have within the model. So now that we've done a facial animation, what I want to do is I want to make material toggles. I want to make toggles that will allow us to turn on and off pieces of our outfit. So that's exactly what I do. I'll add plus to make a new one, and you can see it just repeated the last one, but that's not necessarily what I want. I want to add a new expression. So I'll do here, I'll go create VRM1 expression, and I'll name this wing toggle. And once again here, we will assign our model for preview. We will drag this into here, and we'll edit it from here. Now to do the wing toggle, we will not need to use the morph target menu. So we can go through these other menus. Now this list menu is exactly what we'll need. If we check in this menu, we will notice morph target, and what this is essentially the blend shapes that are being edited. We saw the similar thing in VRM0 models. Actually, let me switch these menus around. Let's put this menu here, and let's put this menu here. So the morph target menu just has these blend shapes listed, but the material color is exactly the menu that we need. So in here we can hit the plus button and we can select our wings. And when we select our wings, we can select their color, and in this case we will do black, and we will set the alpha to 0 as well. you can notice that we can also play with the values and change colors accordingly. And in this case, the wings disappeared properly. So that's our toggle done. But we can also assign some additional settings. So let's go through all the settings available. So in material color, we can not only change the color, but we can change some other parameters as well. So in here, we can change the emission color. And as you can see, when I move around, the emission color will change. Now, if we look in the material, and if we look in wings, what we're changing is this parameter here. If we go back, here we have the option of changing the Matcap color. And as you can see here, we have a Matcap that adds some color. And if we change the color here, you'll notice the Matcap color also changing. This parameter just changes this parameter. And then you have other stuff such as shade color. Shade color is this parameter. Then you have also rim color, outline color, and that is this parameter, and also this parameter. Now, we're not using these parameters, and you can change them if you want, but what you cannot change are these parameters. For example, these settings that define how the rendering of the material works. These parameters you cannot change via toggles. So if you go back into the wing toggle, we will select the color and we will make it black, or rather 0. All values set to 0. So we have some other options here. If you open this menu, you will notice some other options. Here is binary. Will basically determine how the slider works. If we select the is binary option, then the material will disappear whenever we adjust the slider by any amount. So in this particular case, for the closed toggles, I wanna have this option enabled. Then we also have 3 new parameters that we did not have in VRM0 format. So the override blink, here we have 3 different options. The first option is block. If we set it to block, what this means basically, if the model is blinking and this is set to block, whenever this toggle is enabled by any amount, then the model will not be able to blink. And it's similar to for these options as well. If we have override look at, if we set it to block, this will basically not allow the look at component to work whenever this material is assigned. And it's the same case for mouth. For example, if we take an expression, say happy, and we assign the override mouth to block, whenever we talk, the happy expression will remain, but the mouth will not move. So these parameters, lip sync, will be blocked. Override blink blocks the blink parameters, and override look at blocks the look at parameters. Now, additionally, you have the option of blend. And what the blend option does is if this parameter is set to a slider value of 50%, then it will only block 50% of these. This is a new feature that's available in VRM1 format that was not available in VRM0. But in this case, we'll select all of these as none because I just do not want to deal with them, and we'll pretend they don't exist. Next, you have this menu, which is texture transform. And in here, you have the all properties to select the texture, for example, wings, and adjust their coordinate position. So here we will select, so here we will increase the color value. And here, as you can see, if we adjust the coordinate position, we adjust the texture of wings. Now, in VRM0, these were the ST parameters that we could edit. In VRM1, they added a proper GUI, and it should work properly as well. I haven't really played around with this, but in general, you will never really wanna adjust these, because you will need to set up the model yourself if you want to adjust these and if you know what you're doing. So we'll delete this parameter, we don't want it, we don't need it, and we'll assign this back to an alpha value of 0. So that's this toggle done. Now we'll make some other toggles. So here I'll make a necklace toggle, and we'll go back into the list here. We'll right click, create VRM1 expression, create VRM1 expression, and we'll do necklace toggle. We'll drag it in here, double click it, select the preview prefab of our model, material color, enable as binary, and here we select the gold one, I believe it was. You can watch it in the preview. Gold one, yep, that makes our necklace disappear. And then we'll add a couple more expressions. So this one will be dress toggle, assign preview prefab for model, take the dress, is binary, yes, the dress disappears. Next up we will do boot toggle, shoe toggle, toggle. Once again, select our prefab, serialized property boots, and in this case you will notice that the boots do not disappear. So why is that? That is because the boots material is not using a cutout or transparent shading. So if you go into the boots material, we will notice the alpha mode set as opaque, and we need cutout or transparent. So if we set this to cutout, and then if we go back to the toggle that we made, I forgot to assign it. Now that we see that the shoes do in fact disappear. Next, we'll make the tail toggle as well. So here, create VRM1 expression, tail toggle, assign it here, assign preview prefab. It's a lot more faffing around in this version than it was with VRM0. But, oh well. And you can see here that the tail did not disappear as well. And that's because it is also not using the alpha mode of cutout or transparent. So here we'll set it to cutout. And if we go back into the expression, now you'll see that the tail has actually disappeared. And that's partly why I have this second menu here, so that we could navigate files a lot faster. Right now, I want to add a toggle for left sort and right sort. So here I'll make, once again, new expression, right sort toggle. I'll assign it in here, assign a prefab, and we will do right sort. As you can see, this is exactly why we did two materials, so we would have two different options. And if we would not have exported the model, we would not have these options because they would not be present in the metadata. So here we will assign toggle, and as we can see here, the weapon did not disappear, so we'll find the curved sort. We'll change the left sort to cutout, and we'll change the right sort to cutout as well. Go back into the toggle, and we'll notice that it works now. And same thing with this one, though we will rename it to left sort toggle. Assign it. Oh, forgot to click the plus button. Assign it here. Do here. And since we copied it, we could just change this parameter. There we go. There we go. I think that is all that I wanted to set up. So what we'll do now is we will export the model. And to do that, we will select the model in hierarchy. We will go VRM1, export VRM1. In case you press this button and nothing appears, you can simply drag this model in here. And then we will go through the metadata of this model. So here it's self-explanatory, how many authors, how many references, model name, version. You can write anything that you like. Here is licensing information, so you can also adjust to whatever you want. I usually allow everything. Next, we will go into this mesh menu, and this menu, you can ignore this menu. There's nothing useful in here. It just gives you some basic information. Then we have export settings. And as you can see, the only real useful button, reduce blend shape, is disabled because this version does not support this button. If you hover it, it's even mentioned, not implemented yet. So maybe it will be implemented in the future. And these other buttons, they don't really do anything. You don't need to worry about them unless the program yells at you. And now that we have that done, we will hit the export button. We will select where to export the model. In this case, I'll go butterfly, sure, why not? And I'll rename it here, final butterfly model. And we will export everything from the model. So now that we have our model, we can upload it to a 3D application of our choice. In this case, I'm using VroidHub, and we can drag it in, name it butterfly model. Upload, and here is our model that we just made. And in photo mode, we can play an animation just to see how everything works, how the dynamics work. This seems fine. We can also go into the facial expressions, see how they work now that we have them set up. So dress toggle works. Left sword toggle, that works. Necklace, right sword, left sword. Screaming, this facial expression works fine. Then we have shoes, tails, wings. As you can see, it all works properly. So I hope you enjoyed watching the video, and in case you missed how to edit VRM0 models, you can click on this video here. There's some other information that I may have not mentioned in this video, but if you watched both of them, you should be a VRM master about now. So best of luck and see you next time.